Here we go, everybody. This is the first lesson in our very last unit of the semester. This entire last unit, we'll be learning about something called systems of linear equations. So it sounds really fancy, like a system. Okay, well, what's that? All that is just two or more linear equations. And the reason it says or more, when you take Algebra 2 in a couple years, you'll do 3 equations, maybe even look at 4. But in Algebra 1, we keep it basic, and we just do a system that has 2 equations. Now, the word linear should jump out at you. We've just spent an entire unit on linear equations. Linear equations just are lines. Okay, so we're still talking about lines, and this unit plays off of last unit pretty well, which may be really good, but also may be really bad in some reasons. So we'll kind of discover that as we go, but it sounds fancy. A system, you guys, is just two different equations together. So that's a system, this is a system. Sounds fancy, it's not, it's two equations. Okay, so the majority of the unit will be spent solving systems. So finding out like what x's and y's work in both of them. There's actually 3 methods for solving a system. So that's what we're going to start off this unit with. We're going to learn about the 3 different methods. Today we're going to do method 1, which is called graphing. And the reason we do this one first is because it feeds off of what we did last unit perfectly. Okay, so essentially there's really like no new skills here. If you can graph a line, this should be super easy. The thing I want to point out though, the solution to a system, so when I look at 2 equations at once, the solution is just an ordered pair. Or in other words, it's an x and a y. So let's introduce it by looking at this system right here. These 2 linear equations, they're both lines. If I put them together, it's called a system. Now let's check to see if the ordered pair, because I know answers are ordered pairs, let's see if this ordered pair works, -1, 4. And what I mean by works is it makes both of them true when you plug in -1 for x and 4 for y. So let's do that in both of them and see if it makes them both true. So in the first one, I would plug in 4 for y, and x is -1. So -1 plus 5, okay, that's 4. Yeah, 4 does equal 4. That's true. That means that that ordered pair worked in that equation. If I do the same thing for the second equation, I get 4 equals 4, and that worked. So if an ordered pair makes both equations true, that means it's a solution. So this would be your answer to your system here. Now let's kind of discover how we use graphing to pick out the answer. Because obviously they're not going to tell you the answer up front like we just did right here. They're going to give you the system and they're going to say, hey, tell me the ordered pair that works in both of these equations. One method for figuring that out is by graphing the lines, and then you can use the picture to pick out that specific ordered pair. So let's do that. What we're going to do is we're going to take these 2 lines and we're going to graph them together on the same coordinate plane. And then we're going to see what we notice about where the solution lies. So here's where it's really nice if you did like pretty well last unit, if you picked up good skills, if you can graph a line, this should be a piece of cake. If you struggle with graphing a line, this is going to be a struggle. Okay, so here's where algebra kind of snowballs on itself, and you gotta have old skills to do the new stuff. So to graph this first line, it's in mx plus b. The b value is 5. So I'd start at 5, and my slope is 1 over 1. So I'm going to go up 1, right 1. Okay, I can count the slope the other way by going down 1, left 1. That's kind of going to be important today. And I'm going to write a couple tips at the bottom, but if you guys notice, I plotted like an unnecessary amount of points, it might seem like. But that's going to be a tip I give you down here when we start doing these problems. So bear with me for now. When I graph the second line, and I'll do this one in green, the y-intercept is 0, and the slope is -4 over 1. So I need to go down 4, right 1. I'm going to count the slope the other way too by going up 4 and left 1. So there's that line. Now, where's negative 1, 4? Well, that's left 1, up 4. That's this point right here. And if you notice, and this is the big idea for the entire lesson, guys, graphing a line should not be brand new to you. The only really new idea for this lesson is that the solution to a system, to equations, is where the two lines cross. Okay, that's exactly where that point appeared. That's the point that works in both of the equations. So if you graph both of the lines, where they cross, that's your answer, that ordered pair. It's like the one ordered pair they both have in common. Okay, so that is like the goal for today. Be able to graph the two lines, see where they cross, write the solution. All right, so let's just practice a couple. I'm going to graph this first line in pink. So the y-intercept is negative 3. And I'm going to go up 1, right 2. All right, I'm going to write a couple tips right here, like I said I was going to. Couldn't hurt to write these two. Tip number 1, you want to be in mx plus b. Okay, if it's not an mx plus b, like this second line, I'm going to move it into mx plus b. Okay, second tip for graphing, and that's kind of why I stopped mid-line right here, you want to plot a lot of points. The reason that I am suggesting that you do that is because it makes seeing the answer so much easier. So say plot a lot of points, makes seeing the solution easier. It would be really smart, you guys, to take these two notes right here, to write down these tips. If you plot a lot of points, all you have to do is look where you had 2 points land on top of each other, and there's the answer. It's really clear. So I would just go up 1 over 2 until you can't anymore. I would also count the slope the other way by going down 1, left 2. Okay, the more points you get on there, the easier it is to see the solution. So I'm going to graph this second line in green. Here's where the tip comes in. You want to plot a lot of points. You want to be in mx plus b. So you need to solve this for y. Here's where another old skill comes in. If you struggled solving an equation for y or getting into mx plus b from last unit, this is going to be difficult. Okay, I have to assume, for the sake of being able to teach you this new stuff, that you can do that. So if you can't, you need to get help on it. Okay, so I'm going to subtract x. And then I have 2y equals negative x plus 6. Then I divide by 2. Be careful with your signs right here. And guys, the fraction in front of x is negative 1/2. So that's your slope. Be careful with your signs. Be careful how you're doing this part, because if you mess up solving for y, you're not going to get the right line, which isn't going to get you the right answer. So you should get negative 1/2 x plus 3. So that one starts at positive 3, and I count my slope by going down 1, right 2. And okay, right there. Do you see how I landed on the pink line? Like those ordered pairs matched up? Right there, I have my answer, so I can kind of just draw the line, put the solution in. That's the point where they cross, so that's the solution. That's the ordered pair, 1, 2, 3, 4, 5, 6, 0. Now, you can check your solutions. Just realize that. And I don't necessarily expect you to do this on like all your practice problems in class, but of course if you had time on a quiz or an exam to check, you should. If you plug in 6 for x and 0 for y into both of these, it should make them both work, just like we did up here. I'm just going to do that on this one for the sake of time. I'm not going to do it on the rest. Know that you can check. I just want you to be aware of that. So in the first line, I'd plug in 0 on the left, and then 1/2 times 6 minus 3. Okay, half of 6 is 3. 3 minus 3, yeah, that equals 0. So it worked in the first line. If I plug it into the second line, that'd be 6 plus 2 times 0 equals 6. So I would just want to make sure that worked. 2 times 0 is just 0, so yeah, 6 equals 6. It worked. Okay, so be aware that you can check these answers. Great thing about math. All right, I'm gonna be bold, and I've only done one example. I'm gonna have you try one already. So I want you to see if you can do this one. If you can graph those two lines and figure out where they cross and write your answer. Okay, on the back, we've only got two more. And I want to teach you and show you that there are two special cases, like across the board this unit when I'm looking at systems. So most of the systems, there's one answer, there's one ordered pair where the lines cross, there's an X and a Y that work, and that's it. So most systems have one answer. But there are two special cases where there's either more than one answer or maybe less than one answer. So we need to kind of explore those two special cases right now. So example 3, I wouldn't recognize this as anything different just by looking at it. I know that I got to graph the two lines, so I would do the first one, and I would suggest doing two different colors. I don't know, I feel like it just helps. So I'm going to do the first one in pink. It's already an mx plus b. So get the y-intercept. The slope is 4 over 1, so I go up 4, right 1. I'm also going to go down 4, left 1, because I know it's important to get a lot of points on my line, so I can see the answer better. For the second line, I'm going to do that one in green. It's not an mx plus b, so I need to add the 4x over. Ooh, that's positive 4x. Oop, minus 4. Don't mess up your signs like I just did. It's 4x minus 4. Be careful. Okay, now I'm in mx plus b, so the y-intercept's negative 4. That's 4 over 1, so that's going to go up 4 over 1. Up 4 over 1. Okay, I could go down 4 and left 1. All right, this is different. This is weird. Exactly why it's a special case. So if you kind of take a step back and look at this, what do you notice? Well, I should notice that these lines are parallel. We learned about parallel lines last unit. Parallel lines never cross. And if I look at these, you guys, they have the same slope. So remember we learned that last unit. Parallel lines have the same slope, 4 over 1. So I got to fill in a note down here about parallel lines. I told you on the front, the big idea was that the answer is where the lines cross. So think about it, parallel lines do not cross. So that means they have no solution because they never cross. There is no ordered pair, no x and y that I can plug in that's going to work in both of these equations. It just does not exist. So no solution if you ever see parallel lines. Okay, number 4 is a different special case, but again, I probably wouldn't notice that just by looking. So I would just graph them like any other example. So the y-intercept's 3, I'd go up 1 and right 5. I could also go down 1 and left 5. Okay, the second line I see is not an mx plus b. And if you notice a pattern, you guys, they're going to do that to you on like every example. One line's going to be an mx plus b, one line's going to be in standard or something besides mx plus b, because we're trying to test your skills if you can solve for y. So I would just divide by 5 on that one, and I would get, be careful, the slope is 1/5 plus 3. So I'd start at 3, I'd go up 1 right 5, I could go down 1 left 5. Okay, what do you know? These lines, and look at the equations, they're the exact same thing, 1/5 x plus 3. So if you get this situation when you're going through and solving your systems, and it's the exact same line, again, think about how many solutions this has. I told you that the answer is where the lines cross. These lines cross at every single ordered pair. They have every ordered pair in common. That means that there's infinite solutions because they cross at all points. Any single ordered pair on this line, you can plug in to both equations and it would work. Okay, so we got to be on the lookout for those special cases, and that's your first lesson in systems.